Welcome back, focused learners. Okay, so picture this, a massive vessel slicing through the open ocean, the cinematic light catching its hull as it carries the literal lifeblood of global trade. Today, we're unpacking the sheer high-stakes logistical feat of ocean transport in this explainer. So let's just dive right in and decode the ultimate voyage briefing. Think about it. How on earth do you safely move 55,000 tons of cargo across unpredictable oceans? I mean, it's a monumental question, right? The answer actually lies in this hidden world of invisible blueprints, rigid physics, and absolutely non-negotiable international laws. A single miscalculation here doesn't just mean a dip in revenue, it can mean total disaster. So in our explainer today, we're going to reveal exactly how these floating titans actually operate. Section 1. Measuring the modern cargo ship. Before you can even think about sailing, you've really got to understand the sheer physical blueprints and weight capabilities of your vessel. When we break down a ship's weight, you'll constantly hear its capacity described as deadweight. But there are two absolutely crucial terms you need to know here. Deadweight all told, or DWAT, is the absolute maximum weight the ship can carry. We're talking cargo, sure, but also the fuel, the fresh water, and all the spare parts. But if you're a charterer trying to make money, the real magic acronym is DWCC, Deadweight Cargo Capacity. That's the weight of your actual revenue-generating payload, after you've deducted all that fuel and stores. You know, you really have to know what you're actually getting paid to move. Now, here's the curveball. In shipping, tonnage isn't always about weight. It's actually often about volume. Following a 1982 IMO resolution, ships are measured in gross tonnage, or GT. This calculates the total internal volume of literally all enclosed spaces, and it's what dictates the ship's safety regulations. But then you have net tonnage, or NT, which strips away all those non-earning spaces like the engine room and the bridge. NT is strictly the volume of your cargo spaces. And guess what? That's the number port and canal authorities use to charge you fees. So, yeah, it's pretty important. Looking at our vehicle options here, just take a second to notice the sheer scale. You've got a general cargo ship with a gross tonnage of maybe 5,000 and a deadweight of 8,000. But then, contrast that with a bulk carrier sitting at 18,000 GT and 36,000 deadweight, or, even wilder, a container ship at 25,000 GT and a staggering 54,000 deadweight. Having these numbers on hand allows voyage estimators to know exactly what kind of mechanical beast they're actually working with. You'll also notice two very distinct volume measurements being used. Grain capacity is exactly what it sounds like. It's for bulk cargo, like loose grain or coal, stuff that can literally just flow all the way out into the very edges and crevices of the hull frames. But if you're carrying packaged goods, boxes, pallets, that sort of thing, you have to use bale capacity. This is measured strictly to the inside of the frames or cargo battens because, well, solid packages can't magically melt into the nooks and crannies of the ship. And that brings us to a very specific, almost golden number in this industry, 35.3158. While the whole shipping world is increasingly going metric, dry cargo practitioners still heavily, and I mean heavily, rely on cubic feet to describe cargo stowage. 1 cubic meter equals exactly 35.3158 cubic feet. Bridge officers and charterers are just constantly multiplying and dividing by this exact metric to map out their loads in the real world. Section 2. Load lines and safe sailing. So moving forward, we're shifting from those internal dimensions to the environmental limits and safety margins required to keep this colossal vehicle afloat. Enter the Plimsoll mark. Devised way back in 1890 by a British politician named Samuel Plimsoll, this was a truly revolutionary answer to ship owners who were recklessly overloading their ships and endangering their crews. The Plimsoll mark is basically a visual calculation painted right there on the hull. It defines the safe freeboard, which is the distance from the waterline straight up to the weather deck. Make no mistake, it is the ultimate, non-negotiable safety boundary. Now, that mark isn't just one single line. It's actually a series of kind of cryptic letters dictating the 6 load line zones. We've got TF for tropical fresh, F for fresh, T for tropical, S for summer, W for winter, and WNA for the notoriously treacherous winter North Atlantic. Because weather and water density change globally, like a ship actually floats higher in dense saltwater than it does in freshwater, these marks dictate exactly how deep a ship can legally sit in the water. It all depends on where it is and what season it is. This requires some incredibly strict geographical foresight. For instance, if a ship is passing through a summer load line zone, it can only load down to the top of the summer line and absolutely no further. This means voyage planners have to look days, sometimes weeks ahead. You literally cannot load to your tropical marks if your route is taking you through a harsh winter zone next week. If you do, you're directly violating international law. Section 3. Powering the voyage. Now that we've got our dimensions and safety perimeters perfectly mapped out, let's take a look at the massive, beating heart of our operation. Powering a behemoth like this requires some seriously strategic fuel management. You have two main lifebloods for the ship. First is intermediate fuel oil, or IFO. It's a heavy, low-cost residual fuel. This is your brute force, used for long, open ocean cruising. But the catch is, IFO responds very slowly to throttle changes. So when the ship approaches a tight, congested harbor and needs instantaneous response from the engines, they have to switch to marine diesel oil, or MDO. It's much lighter, acts a lot faster, and ensures the ship can actually maneuver safely. But honestly, fuel is also a massive logistical risk. Bad bunker fuel can literally dissolve an engine. I mean, it's wild. That's exactly why charters stipulate ISO 8217 standards. It's to prevent unscrupulous suppliers from dumping literal dry cleaning chemicals into marine fuel, which has absolutely caused catastrophic engine failures in the past. On top of that, ships must navigate emission control areas, or ECAs, which mandate carrying entirely distinct low-sulfur fuels to comply with environmental laws. It's this incredible high-stakes balancing act of daily consumption rates, whether you're out at sea or just idling in port. Section 4. Mastering the cargo load. Next up, we're shifting our focus to the giant geometric puzzle of actually fitting the payload inside the ship's hold. Okay, so the absolutely crucial point here is understanding stowage factors. Imagine looking down into a massive ship with a 55,000-ton deadweight limit and a 2 million cubic foot hold. If you load iron ore, which stows super heavily at about 13 cubic feet per ton, you hit your 55,000-ton weight limit almost immediately. The ship is maxed out on weight, but the hold is only like a third full. Now, contrast that with coke. Coke stows incredibly light at 80 cubic feet per ton. Just 25,000 tons of coke will completely fill that 2 million cubic feet of space, maxing out your volume while leaving over half your deadweight entirely unused. It's this extreme physics puzzle that operators are solving every single day. Let's move on to the concept of self-trimming. Basically, this is a bulk carrier designed with angled upper hold sides that let bulk cargo just naturally flow laterally across the compartment. The idea is that you don't need extra shore equipment to push it into the corners. But you have to be careful. Not all bulk cargo flows easily. Scrap metal is a great example. That's exactly why a lot of operators actually prefer the term easy trimmer over self-trimmer. Calling it an easy trimmer manages expectations, and it really helps avoid some terribly expensive legal disputes over who has to pay for shore assistance if the cargo doesn't settle perfectly. And of course, we can't talk about cargo without talking about risk. Ship owners definitely want to protect their multi-million-dollar assets, so they strictly categorize dangerous goods into 4 areas. Category 1 is cargo that can imperil the ship entirely, think volatile explosives. Category 2 is cargo that can corrode the ship's structure, like sulfur. Category 3 is cargo that's highly dangerous to the crew itself, like toxic ferrosilicon. And Category 4 is cargo liable to damage other goods on board, like copra. Knowing exactly what is going into the belly of that ship is absolutely paramount. Section 5. Clearance to sail. All right, we've reached the final phase of our briefing. We have our ship, our fuel, and our cargo. Now we just need the green light. A massive vessel like this isn't going anywhere without navigating an absolute mountain of high-security paperwork. Just consider this rapid-fire checklist of flag state documents. You need a certificate of registry, your load line certificate, safety construction and equipment proofs, a safety radio certificate, which, depending on its A1 to A4 rating, actually dictates if you can sail coastally or globally, and a minimum safe manning certificate to prove you have enough crew on board. Listen, if even one of these is out of order, port authorities will instantly drop the hammer and halt the whole operation. Welcome to the modern era of shipping security, the ISPS code. Formed rapidly after the events of 2001, this code mandates a highly dynamic security protocol for literally every vessel and port worldwide. It starts off with a rigorous risk assessment, followed by a detailed security plan that gets audited by a recognized security organization. In practice today, both ports and ships operate on a dynamic 3-stage security alert level. And it's simple. If a ship lacks an ISPS certificate, it will be denied entry to ports, period. Finally, there's the ultimate health check, classification. Organizations like Lloyd's Register, which by the way dates all the way back to 1760, assign a class notation to a ship. To maintain that notation, the ship has to undergo a grueling special survey every 5 years. This literally requires the massive vessel to be completely dry docked. These rigorous top-to-bottom inspections guarantee the ship's condition, which is the absolute baseline for securing insurance and actually attracting charters in the first place. So here we are at the end. Next time you gaze out at the ocean and see a massive cargo ship framed against that cinematic horizon, what are you going to see? Will it just be a slow-moving vessel, or will you see the brilliant, invisible blueprint of deadweight math, load line physics, complex engine logistics, and strict global security that literally keeps the entire world's trade afloat? It's a breathtaking orchestration of science and strategy. Thanks for joining me on this Explainer, Focus Learners. Keep asking questions, keep studying those blueprints, and I'll see you next time.